Okay, so let's quickly have a look at these. They're not that tricky. Okay. So let's have a look. X squared plus 1 equals 0. Let's not miss any out for any sort of details out for the first one. Let's show every line of our working. So first thing we're going to do is take away 1 from both sides. Okay, so x squared plus 1 equals 0. You're going to take away 1 from both sides. And then hopefully what you're going to do is take the square root of both sides. But of course, if you take the square root of both sides, are you happy? You're going to have to put plus or minus. Happy with that? Yeah? Now here's a question. If I say x squared equals 9, what are the solutions to this equation?
3.
Is that it?
3 plus I0.
You could write it if you wanted to write it as a complex, but is this the only solution which is valid for this equation? Good. So you can have x equals positive 3 or x equals negative 3.
True.
You happy with that?
Yeah.
Okay. Now if I ask you this question, square root of 9 equals x, okay, what are the solutions to that equation? Sorry? Just 3. Why is it just 3?
No, it's like 3 and or negative 3, right?
It's not. It's not. It's just positive 3. Okay. Now, does anybody know why it's just positive 3? So this thing up here, if I have a number, this is literally saying I have a number, I square it, and it's equal to 9. The solutions are 3 or negative 3. Because if you square 3, you get 9. If you take the square root, if you take negative 3 squared, it's also equal to 9. This thing down here, though, has only one solution. This is literally asking a different question. It's saying, what is the square root of 9? And if the square root of 9 is just positive 3. Hence the reason why I have to put plus or minus 3 out the front of my square root, to make sure I capture both the positive and negative root, because it's coming from something which is squared. Does that make sense? Okay. But does anybody know why, when you have x squared equals 9, there are 2 solutions, and when you have the square root of 9 equals x, that's only got 1 solution? Okay, I'll show you it from this perspective. Do you remember our definition of a function? So when I did functions with you, okay, I said to you with a function, let me just literally draw it, okay. When we had our function, okay, I said you put your value in, let's say x, and you get your output out, which is y, okay. Now I said to you the rule of a function is 1 value in, 1 value out. So you can't put 1 value in and get 2 values out, okay. So every input has to map to 1 output and only 1 output. That make sense? Yeah? So what I need to do is I need to think about this. If I have x squared equals 9, my function is x squared. What does the function y equals x squared look like? What does the function y equals x squared look like? Just a parabola, right? Just that. That's y equals x squared. Okay? Which means that if I'm looking at what value when I square it, so what value when I square it gives me 9, there are 2 solutions. There's one over here and there's one over here, because they both have a value of 9. That makes sense? Mm-hmm. Okay. Now let's have a look at this, because really what I'm asking now is this, square root of x. Okay, y equals the square root of x. So this is really looking at y equals x squared. This is really looking at y equals square root of x. Does anybody know what the function y equals the square root of x looks like?
Will be a line or?
They're inverse functions, right? Because it gets you back the other way. Mm-hmm. Okay, so a function gets you from here to here. The inverse function takes you back the other way. So it must be a reflection of the line y equals x, because that's what happens when your x and y swap places. Okay, you're literally, your inputs and outputs swap places. Okay, so if I reflect in the line y equals x, I get this graph here. Okay, happy with that? Just simply reflecting the line y equals x. But now does my definition of a function hold? If I put 1 value in, do I get 1 value out?
No.
No, because if I put, say, this value here in, I now can, you see, I get 2 values out. Okay. So what we say is to stop this function of a definition of a function being violated, we just stick to the positive root. I guess we could stick to the negative root as well. Okay. But now can you see, if we just say that if we take the square root of a number, it is the positive root, not also the negative root as well, we no longer have this violation of a function. We now put 1 value in and we get 1 value out. That makes sense? Okay. There are other sort of proofs and definitions of why that has to make sense as well. This is not the only one, okay? But there are other situations as well. Otherwise you get weird things like 2 equals 1 or something, okay? So let's have a look. I might show you that in just a second. So yeah, just be aware, if you have a number, which when you square it equals something else, to get that solution, you also need to take the positive or negative root. Now, of course, what is the square root of negative 1? What did we say that was equal to? I. Good. So the solution to this equation, x squared plus 1 equals 0, is plus or minus I. Make sense? Good. Okay, let's do this one. So x squared equals negative 4, okay, which means that x must be equal to plus or minus the square root of negative 4. Can we do anything with that? Because we're taking the square root of a negative number, square root of negative 4, can we write that in terms of I, given that I is equal to the square root of negative 1?
2i.
Good. Let's show you where you got that. So you get plus or minus the square root of 4 times the square root of negative 1. You happy that's true? Because I think of negative 4 as 4 times negative 1. That should be equal to the square root of 4 times the square root of negative 1. And what is the square root of negative 1? It's I, right? And what's the square root of 4? It's 2. So it's plus or minus 2i. Happy with that? Yeah? Mm-hmm. Okay, good. Let's quickly do this one. So we have x squared equals negative 5, which means that x is equal to plus or minus the square root of negative 5. What would that be equal to?
Square root of 5i.
Good. So you can't do anything with that square root of 5 now. So the square root of 5 times the square root of negative 1, or the square root of 5 times by I. What about this one? X squared equals negative 12. X must be equal to plus or minus the square root of negative 12, which means that you get plus or minus. Square root of 12 is going to be 2 root 3 times I. You all happy with that? I'm just kind of getting through there because I'm aware that I've been talking for a long time. This one is a quadratic equation, okay? You could try and factorize it, but you probably won't get very far. So I would solve it using the quadratic equation. You happy with that? So you get minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, so 2 times 1, okay? Bit of tidying, negative 6 plus or minus the square root of negative 64, all divided by 2. You can deal with the square root of negative 64 as 8i, because square root of 64 is 8, times by the square root of negative 1. And if you divide both of those things by 2, you get negative 3 plus or minus 4i. Is that okay? Are there any questions about that?